Welcome back to Ox Tools. I'm Tom. So we're building another Meatloaf here, and we got a few things to do. Got a few tools to show. We had some questions about stuff people saw in some videos, and I got a story to tell, and we're also going to do the first parts of the Z-scale for the digital readout for the lathe. So people have been asking me about the, why haven't I put the Z-scale on the lathe? And the answer is it's kind of tied together with several other things that I want to do at the same time. So I've been scrounging materials and kind of getting my plan together, and so when I move the lathe to do the scale install, I can do everything at once. So so we're going to start in on that a little bit. There's some pieces that we can work on and kind of get ready to go. So let's go look at some tools first, and then we'll do some shop work. And I'll figure out who's texting me and sort that too. Okay, so believe it or not, I get quite a few comments about this silly little wrench right here. You guys have probably seen this on my vise here. It's just kind of a quick wrench, and for kind of lighter work in the mill. And it's made from a cut-off, crappy. Well, it probably wasn't a crappy. Maybe there was something wrong with the other end, and it's a flea market combination wrench that I lopped off, and then, oops, did I bring it? Oh yeah. And then there's a company that sells fencing supplies, for like ornamental iron and stuff like that, and it's all this cheap offshore steel and cast parts and forged stuff. Anyway, they have all these hollow spheres. And that one's hollow, although it's kind of hard to tell. It's pretty thick. And you can get hemispheres also. Anyway, I bought a couple of them, and in fact, you can kind of see the weld seam there. And, it's just kind of nice in the hand, right? Because, a lot of times you're hitting that with your palm, so it's just a larger contact area. Now, for heavier duty tightening, I kind of use this one here. And this is a Kurt speed handle. This came with the milling machine. I'm pretty lucky to get it because Kurt doesn't give. Oh, hey, look at that! Kind of cool. My balls are rotating because Kurt doesn't give these things away. But this is solid steel, which is really nice because the aluminum hubbed ones, the little offshore cheapo ones, they just bend. They're crap. And so if you're going to get one of the steel ones, or make one. Now, this is a really good make-it-yourself project here. So, and this particular mill has this problem. Now, this is a stock Kurt handle here, and that comes with it. And these work pretty good. And you can, they've thought about the ergonomics of this. And but here's the problem: is this gets mixed up here. Okay, so that's pretty lame. So I believe that this particular mill is just slightly different height this way in relation to a Bridgeport or some of the other models, or maybe this, maybe this handle's bigger. I don't know. It kind of almost comes to center line there. See, oh yeah, that's what it does. Now I remember, right? It gets locked in there. There's a spot that it can get snagged, and it really pisses me off. So. Anyway, that kind of sits in the drawer unless I really gotta, I really want a reef on something there. So anyway, that's that. This is really simple to make. This could be a really big ball bearing, any kind of metal ball, or some clever pipe fitting or something. I don't know what, but just something that spreads that, spreads that area out, so that you can hit it with your hand and not narf up your hand. Anyway, that's the vice wrench. Alright, so this next one, let's get that out of the way. This next one is for my friend in St. Louis, Gent Harris, Richard Harris, and he works in a big shop back in St. Louis. does some pretty cool repair work and machine work back in their shop. I don't think I know the name of his shop, but he and I trade pictures back and forth and stuff we're working on during the week. Anyway, he spotted this wrench here. He says, "Oh wow, there's somebody that doesn't use a crescent wrench on their tool post nut." And I was lucky to find this wrench. This is an old pre-proto Plum, 1.5 inches on one side and 1 7/16 on the other. And this is what they call the pebble finish, which is kind of this old-timey World War II finish. But what's neat about this wrench is it doesn't weigh crap. Okay, it doesn't weigh anything. Look how thin it is for how big this wrench is. So I really like this, and it's got a nice little feel to it. It's got a little spring to it, and it's just kind of this lightweight wrench. It's surprisingly light. Anyway, that's for Gent, my buddy Gent, back in St. Louis, and there it is, 1.5 inches. He guessed at 1 5/16, but he was pretty close. And but it's 1.5 inches. Anyway, thanks, Gent. Okay, so if you if you believe it, we have another installment in the Noga indicator saga. So you guys have all seen these. I'm not even going to talk about them. These are these wonderful Noga indicator holders, and this is little baby Noga, and this is Mama Noga here, okay, and this is the one that most folks get, this particular length here. So we got baby Noga, Mama Noga, and then we got Papa Noga. So this is they call this the big boy. Let's make sure you guys can see the whole damn thing. It's ridiculously large. I was joking with Adam, and I said, you could put a tractor seat on this and sit on it almost. So it's got this gigantic double barrel magnet, and this thing's almost, I don't know, it's over 3/4 of an inch in diameter. And it's about 3/4 of an inch in diameter, and it's got the little itty bitty indicator holder out on the end. Anyway. I got this at work because we have some bigger machines at work, and so I kind of borrowed it for the weekend just to show you guys just physically how large this thing is. So if you're thinking about buying one of these, I hope you got a big boring mill or a horizontal boring machine or something like that that could warrant that, and because it's a tank. I mean, look at it. This cracks me up. So. It's so physically big. Anyway, kind of funny. Okay, so while we're on the subject of big boys like this Noga here, the next thing I want to show you guys is a hammer that comes from Sweden, and it's pretty impressive. And so I really like to show that to you. It's quite spectacular. So let's get it up here. It's making its entrance. Whew. Okay, now let me get in close so you guys can see this thing. Okay, so this hammer, I'm going to open it up here. This hammer comes to us from Daniel Jansen. He's in Umeå, Sweden. And he says in his note, I figured since you're collecting hammers and that you've had a bit of a tool size competition with other people, it was time to backpedal. Why go bigger when you can go smaller? Hope you enjoy your new tool. If you want to see it being made, head over to, and then here's the link right here to check out the video of it being made. So Daniel Jansen in Sweden made this hammer for me. He is doing his master's on interaction design, which is mechanical design of, and he's doing his master's thesis on it. And this is what Daniel made. Isn't that wonderful? So this is he made the box and everything. Look at this. It's all cut out with an X-Acto knife. And he made a beautiful label here. Original switch and lever brand. Size XXS, ½ ounce. Okay, so let's pull this out of its little resting place here. It's a little brass hammer. It's almost like a little farrier's hammer. It's basically flat on both sides. Wooden handle that's been varnished. It's thinned, as you can see here. He doesn't say what kind of wood it is. I'm not sure what kind of wood it is, but it's just spectacular. So it's about 25 millimeters across, 1 inch, and then the length, you know, we're 2.5 inches here. It's just it's just spectacular. I'm really impressed, and I'm touched, Daniel, that you took the time to make such a thoughtful gift for my hammer collection. Anyway, I'm very impressed, and thank you very much. And serial number 001. Okay, Adam. So I don't know. I'm thinking this one might be a little bit smaller than the ones you have that folks have made for you. So we might have a downward size competition going on. Anyway, be sure to check out Daniel's channel and his video. Here's the link again. And scope out how he made this. And he and I have emailed a little bit back and forth, and he had a lot of fun making this thing, and I really appreciate the gift. Thanks, Daniel. Okay, so we got the these are the materials for the new feet, the new leveling feet bases for the lathe. And this is just some mechanical tubing here that's been cut off approximately the right height, and then we have a cover plate that's going to go on here like so. Those will get welded on, and then there'll be a drilled and tapped hole here, and this is going to be the new leveling feet for the YAM lathe. The digital readout install kind of hinges on this. I'm trying to do everything all at once when I pull it out from the wall there and work on it. So let's we got some belt sanding to do to kind of deburr these. These are just sawed right here, and we're going to face both ends of these so that they're parallel. It's not a precision thing, but it's just a nice cleanup on this so the welding goes smoothly. So let's go do that. drilling and tapping these. I'm going to pop this thing out of here. I'm going to use a Jacob's chuck. Just because we're doing some tapping, it grabs a little better than the Albricks do. Okay. So these have a socket edge, so we're going to clamp them on the factory edge with our using our little stop there, like so. Let me grab some parallels. Okay, and then, because I'm going to put them back in, I'm just going to mark that corner, just because. So I can put it back in the same way, because what I'm going to do is I'm going to drill all these first, I'll swap the parts, and then I'll come back and I'll tap them. So, these are 4x4. Alright, so I'm just going to go right in this. Let me make sure I'm on my absolute. 2x2. And right there. Just locking the table down. Oh, way too fast. That's 500 RPM. Or a little less. So these don't, this isn't any kind of accuracy issue here. These are just leveling feet. So never forget what you're making. Sometimes it just doesn't make any difference where the hole is, or much difference. Okay, so get my handle. So I'm going to swap the parts in this situation here. Okay. Leave that out. And repeat. Okay, so we're going to swap out this tool now. Put this in. So let's do a little power tapping here. Always lube. This is a through hole, so this is pretty straightforward. Swap that out of there. Okay, lube each time. Okay. Okay, so last operation, we're going to just break the edge of those holes, the countersink here. Get those out of the way. And what we're going to do is we're just going to do it up on the flat up here, like so. Because this won't penetrate through there. And it gives me a nice firm surface. Like so. Now what I want here is I want a little bit of space between that and the vise jaw. That way it lines up. But if it catches, it'll come up against the vise jaw. And I'm going to run this in low range. Let's do, I don't know, that looks pretty good. And the reason I'm doing this out of the vise, as you can see, it's imminently quicker because I can just bink, I can just flip it over. I don't have to fart around closing the vise or doing anything. Hopefully you can see that. Okay, that was 16 sides, quicker than weasel snot. Okay, so we're over here we're at the welding table. So what we're going to do is put these together like so. And I've gotten some questions over over the life of the channel, is how come I TIG weld everything? Well, I don't TIG weld everything. I TIG weld small stuff in general. And where I draw the line, it has to do with weld volume. So if there's a lot of material, like this is a pretty good sized fillet weld here, I'm going to go ahead and use the MIG welder just because it's going to be faster because the weld volume is larger. Now, if I was doing that, for example, and I needed a little weld and a little weld, I'd TIG weld it because the weld volume is small and it's much more pleasant welding than MIG welding. So what we're going to do is we're going to look at this space here, and I might bend up a wire to help me gauge the thing or something. Anyway, we're going to just weld those up and make those solid. And then we'll see how these look. I may go back on the lathe and knock those corners off by turning it. And I hope I don't have to answer the question is why did I do these in the mill and not in the lathe if I'm going to turn those? And the answer is because it's stinking slow in the lathe doing all that drilling and tapping. And you saw how fast the drilling and tapping went in the mill. It's just a quicker machine for that kind of stuff. And we don't, if this is here or here, nobody cares. It's a foot for a machine, okay? So that's kind of the reasoning behind that. Okay, so let's get the MIG welder set up. I'm going to put some anti-spatter on the table to protect my nice table, and let's do some welding. Okay, so we're just going to line these up. I'm just looking at this gap here and just kind of making it even on all four sides. And we'll clamp it just so when we tack it, the tack doesn't lift the plate. We'll get 4 tacks on it, then we'll do a little welding. take this out. Okay, let's do some real welding here. Okay, so I got the Z-axis scale unpacked and checking out the hardware here, and getting ready to work on the backing beam for the scale. So I unpacked it, checked it out, everything looks fine, no damage or anything like that. One minor hiccup is I asked for 1 micron scales, and this is a 5 micron scale. Not a big deal. The x-axis is a 1 micron scale, so that would be the one that I would be really annoyed if it wasn't what I asked for. Not worth it to screw around and send this back. I'm just going to work with it like this. So I got this piece of steel here, and this is kind of a support structure for the scale. Now this scale is a little heavier than the x-axis scale. The cross section is a little bit bigger. And but on the back of the machine, there's a couple of raised bosses, and I think it's for mounting a taper attachment, or I don't know what exactly. But anyway, so if I mounted on those, the scale would be something like this, and it would have a hollow underneath it. And I kind of don't like that idea. You know, if you're back there cleaning and you bonk on that or whatever, you could screw this thing up, or I don't know, render it inactive. So what I decided to do is instead to do it like this is to mount this backing bar, and that's 5/8 thick, by I don't know, 2.5, and this is 4140 actually. It's just happened to be what I got. It was scrap steel price. And then what we'll do is we'll mount the scale to that. So now, we've got this extra mass here, meat and stiffener to take care of business there. And then it's got these little clamper deals to mount the scale in a couple of places. So what we're going to do here is in this hollow area, we're going to make some what I call concentric adjusters that will go through, and I'll be able to adjust the scale, or excuse me, adjust the backing bar and indicate it and get it parallel with the machine dead nuts, and then lock those down, and this will be nice and firm even in the where there's air underneath it. So I mean, I'll probably put 4 of those in, something like that, and then it'll be mounted here too. So anyway, that's kind of the deal. Here's the reed head, and then the reed head bracket comes down and puts the reader head, so that it glides along that guy there. And now I know what this is, the spacer shim that to mount the reed head, so I don't have to make one this time. So gotta make some adjusters and then drill and tap a bunch of holes in this, and then we'll get going. Okay, so we're back behind the lathe here, and you can see, and I'm just using the laser pointer here, there's one of the projections, and then there's the other one down there. And so we're going to be spanning between those two with that bar. So the bar will mount here, and it'll mount there, and it'll be cantilevered out beyond that. And then in this area here, we'll have some of those concentric adjusters. So that's what I'm kind of dealing with behind the machine here. Not a big deal. It's just it's just the way this machine is. I don't think it's a big deal. And then at the other end, it's kind of hard to see down there, but this is a gap bed lathe here too, so I got to be a little bit below that gap so that I can the scale can extend all the way, or as far as I can get it, or it needs to be, I should say, towards that end down there. Piece of crap. What's going on? Oh. All right, let's try that again.